So in this lecture, we will learn about the concept of deep and shallow copies of objects in object-oriented programming. So we start with first looking at an example. I have copied that example in Python tutor, which is also can be used as for teaching the concepts of the. So I'm using pythontutor.com, but I'm using their Java tutor. So this particular website is pretty useful if you want to learn or practice programming. In here I have a public class person, and this is a template of the person in which I have two variables, name and age, and then I have methods for retrieving and setting the values of name and age. If we go further, here is the class that actually make use of this person class, and as you can see that I have two objects that I have created, person1 and person2. These are created by calling the new key operator. By using the keyword new, what we do is we demand a place in the RAM. The place in the RAM is granted after this, and then there is a place for the name and then a place for its age, and then the address of that location that has been granted because of the use of new keyword is stored in the variable person1. So we can say that person1 is a reference to the location where this new object is created. Similarly, we created another object, person2, and this is also created by using the new keyword. Whenever we use the new keyword, a new RAM location is allocated. So this is also on a different location. Now in the person p3, we did not use the new keyword. Instead, what we say is whatever is the value stored in person1 is copied in person3. So what we have is person1 and person3 are both pointing to the same location. So do a more visual more visual representation of that. Let me show you a more visual of that. So this would be like this. So let's say person1 location in the RAM was, now I'm just making up these numbers, so for the sake of understanding, at memory location this was the person1. So our person1 reference would be equal to 7068, or you can link person1 to the first first object, and in which we have Ashton, and we have its age set up to be 56. Now we created person2. Let's say wherever it is available in the RAM, that little person guy would be stuck in here, so I think we called it Bailey, and Bailey was 45. Let's say the location that the RAM found to store our stuff is 3074, and it doesn't have to be in sequential order or anything. Whatever is available at that time is given. So person2 is at location 3074, right? And then we can say that that is related to here. Now what we did was we did say that person3 is a new reference. So we say person, although we say that this is the template because that's the class name, then we use person3, and we say that person3 is equal to person1. So what that mean is, but person1 was 7068, so this will also be in location 7068, and where would it be pointing to? It will also be pointing to the same memory location. So now we have two references, person1 and person3, pointing to memory location for person1. So we can say that person1 and person3 are shallow copies of each other because they are both pointing to the same memory location. Similarly, if we generate another person and we have this guy person4, we have a reference. We say that we intend to create a person, but then we call it to be person2. So we know that person 2 was 3074 or whatever is the memory location they have saved. So this will also be 3074, right? So what that means is this person 4 is also pointing to the location here. So what that means is now we have person 1, and person 2, and person 3 are shallow copies of each other. Why? Because they are basically no two different, they are same, pointing to the same location, they are at the same location, right? So they are pointing to the same location, but there are two variables that are pointing to the same location, but they both are referring to the same location in the RAM. Similarly, person 1 and person 3. Now let's say what I do is I make another person which I call person 5, and I make person 5 and I say this is a new person, so I did not give it any value in the beginning. I make an empty person, and then I say that person 5 dot name is equal to person 1 dot name. Okay, so what I did was I take the name of person 1 and copy it into person 5's name, and then I take the age of person 5 and I give it the value of person 1's age. So what I did was I take the values that are stored for person 1 and I copied them into person 5. Now person 5, as you can see that this is I'm using the new keyword. Whenever I use a new keyword, a new memory location is created. So although person 5 is looking situated at a different memory location, but we have made it similar to person 1. So here is our situation if you look at it. So we have 3 memory locations. This is for person 1 that we created, this is for person 2 that we created, and this is for person 3 that we created, right? So person 1, then we have the person 2, and then we have the person 5. These are our unique memory location, but what we did was, because we used a new for each of them, right? Now we have then person 4, but we say that person 4 is equal to person 5, so person 3, I apologize. This is person 3, because we say that. So we say that person 3 is equal to person 1. So both person 1 and person 3 are pointing to the same location. This is person 4, which is also not created without the new keyword. So in here, remember, we had Ashton, and then we have its age. Then we have Bailey, and I have their age. Now although we created person 5 in a different location, what we did was we copied the values of person 1 into person 5. Now person 5 and person 1 are similar, but they are at different memory locations. So we can say that person 1 and person 5, person 1 and person 5 are deep copies of each other. They are deep copies of each other because they are different objects. They live in different memory locations, but their values are similar. Okay, we can also say that person 1, and person 3 are shallow copies of each other because they are actually both are reference types, but they are referring to the same memory locations. So always remember, deep copies have the similar values, but they live in different places in the RAM. Shallow copies are actually referring to the same place. Now, if I change the name of person 1 or use a person 3 reference, they both will be making the ref change in the same location. But if I change the location or name of person 5, although they are similar in the beginning, but I can change it and they would not be related to each other, the change will not be reflected. So this is the difference between the deep and shallow copies in object-oriented programming. It's very important that if you are making if you are just making copy of a reference, that will be a shallow copy, and anything that you do to person 3 and then you use person 1, they actually are referring to the same object and your change will be reflected in both places. Keep in mind, you can give me or send some comments to me, whatever concept that is bothering you, and I will explain to you guys. If you want to have a live session on a certain topic, we can do that as well. Just drop in a comment and like and subscribe the channel if you like this content.